Hello friends, welcome to Engineering Online. Today we will discuss a very important terminology in engineering mechanics, that is composition of forces. So what is mean by composition of forces that we already seen in the previous video? Composition of forces is the addition of multiple forces to get its equivalent force, which is known as a resultant. So this composition of forces is three different methods. First is the parallelogram law of force addition, then the triangle law of force addition, and the polygon law of force addition. So in a previous lecture, we have already seen the parallelogram law and the triangle law, which are very useful to determine the resultant if we have two forces. They are also useful if we have more than two forces, but the method is little bit complicated and tedious. So to overcome that drawback, we have polygon law, which states that if a number of coplanar concurrent forces acting simultaneously on a body are represented in magnitude and the direction by the sides of a polygon taken in order, then their resultant may be represented in magnitude and direction by the closing side of a polygon taken in tail of first vector to the head of last vector order. So to understand polygon law, let's consider the three vectors. Let this is a G vector, this one is a F vector, and this one is a H vector. So if we apply triangle law to determine the resultant of these three vectors, then what will be the approach? We will draw first G vector as the first side of a triangle, then we will draw F vector as the second side of a triangle, and the closing side of these two vectors will be a resultant of these two vectors. Let it is R1. So now consider R1 as a one side of a triangle and use this third vector H. So this is the third vector H. Now R1 is acting as a side of one side of a triangle while H is acting as a second side of a triangle. Now the closing side of this new triangle is again resultant, but it is R. This R is the resultant of all the three vectors. So this is the approach of a triangle law. But in this law, if we remove this intermediate step of R1 resultant, then whatever we are getting is nothing but a polygon law. Now observe the statement and the diagram carefully. If we have a number of coplanar concurrent forces like F, G, H acting simultaneously on body and are represented in magnitude and direction by the sides of a polygon. See here G, F, H are represented as the sides of a polygon taken in the order similar to the triangle law in which we use tail to tip fashion, then the closing side become its resultant. So this is a polygon law. Let's solve this. Let's use this polygon law to solve the resultant of this problem. So in this problem we have almost four vectors acting in a different quadrant, different directions, and they all are the concurrent forces acting on a point O. So the line of action of all these four forces are passing through a common point, and our objective is to determine resultant R by using this graphical method which is known as a polygon. So to determine the resultant of these four vectors, we are using a graphical approach which is stated by the polygon law of force addition. So here again I'm using a graph paper with a unit dimension, and the first step is to define a suitable scale. Because the unit of force is a Newton, and for the drawing we need to consider a proper scale of mm, centimeter or a meter. So with a suitable scale, start with the origin O. Consider any one vector in this sequence. I am considering 80 Newton as my first vector to draw or to start a polygon. So this 80 Newton vector will be on one side of a polygon. So this is the 80 Newton force and it is right now acting as a one side of a polygon. Then I am considering this 40 Newton force which is acting in a first quadrant. So I am considering as a second force in the order with the 45 degree with respect to x-axis, and its dimension is 40 Newton. We need to draw a temporary x and y axis to draw the next vector, which is again a 40 Newton force acting at 45 degree but in the second quadrant. So this is 40 Newton 45 degree with appropriate scale, and the last force in our sequence is a 30 Newton, so it is a last force in the sequence, purely vertical. So right now see, as per the statement of polygon law, I have drawn all these four vectors as the four sides of a polygon, and as per the statement of a polygon law of force addition, the closing side means this side become the resultant, and this angle is the angle of inclination of a resultant. So the magnitude of R we can easily calculate, or we can measure it from the diagram, but simply multiply it by the scale and you will get the value of resultant R. It will come R is equal to 84.3 Newton. Similarly, with the protractor, use this angle phi, you will get phi as 18.37 approximately. So at this stage, one question comes that whether this sequence is important, means I consider 80 Newton as a first force, then 40 Newton, then 40 Newton, and the 30 Newton. So whether this sequence is mandatory, so it is absolutely not. You can use it in any sequence. Let's understand it. So this is the problem that we already drawn with the sequence, and this is the R resultant, and this is a phi. So So in the next sequence, I'm considering 30 Newton as my first vector. So that 30 Newton I have drawn with the temporary x and y axis. Now I'm considering this 40 Newton, which is acting in the first quadrant, as my second force in the order. So this is the next force. Then I'm considering 80 Newton as the third force in the, so see, third force 80 Newton, and finally this 40 Newton, which is acting in the second quadrant in the sequence. So here you can observe this R and the phi are remain same, though we have changed the sequence. One more time, let's change the sequence again. Now I'm considering this 40 Newton as my, then 80 Newton as the second force, then 30 Newton as the third force in the sequence, and Newton, which is acting in the first quadrant, as the last force in the sequence. And still observe resultant R and the phi are remain same. Their value is completely unchanged. So from this you can easily state that the sequence of the forces is not at all mandatory to determine the resultant of the forces. But for the polygon law, we have one drawback, that is this graphical approach is sometimes very difficult if the number of forces are more. For example, if you have a 10 forces, 15 forces, 20 forces in the system, that time this approach is quite difficult to get the resultant of multiple forces. So at this stage, we have another approach to overcome this drawback, which is known as a rectangular force system. So that we will see in the next video. I hope you understand the concept behind the polygon law of force addition.